The objective is to help identify where meteoric water preferentially infiltrates mine reclamation fill materials, contributing selenium, leached from fill material, to the Wells Formation aquifer near the industrial well. This is an aerial view of the mine and survey. The application of the Willowstick technology, as applied to the study area, is based on the principle that groundwater flow paths have an increased electrical conductivity than the surrounding earth materials. Therefore, the electric current highlights areas of highest saturation and transport porosity where meteoric water preferentially flows into the Wells Formation aquifer. Selenium concentrations rise above groundwater standards only during spring months. As a result, the investigation was performed during peak runoff, April 15th through May 17th, to capitalize on conditions most favorable to leaching and mobilization of selenium. For reference, the surface topography contour lines have been turned on. The aerial photo was turned off. The view has been changed to look at the vertical slices of the electric current distribution, or ECD model. The ECD model is an inversion result that calculates subsurface electrical current flow within the survey area based on the magnetic field measurements. The view is looking north. Notice the location of the industrial well and the surface electrodes represented by yellow spheres. Slice positions are given in reference to the industrial well. The slice shown is a vertical east-west slice located 1,250 feet south of the industrial well. The upper and lower boundaries of the Mead Peak Formation are shown in red, dipping roughly 30 degrees westward. The Mead Peak Formation has been mined out from the A panel. Also, the Mead Peak Formation does not exist east of the A panel. Where present, this formation acts as an aquitard, separating meteoric waters from the deeper Wells Formation aquifer. The runoff recharge area is indicated by the yellow lines near the top of the screen and is a diversion structure designed to route meteoric runoff directly down to the Wells Formation. Zooming in closer, the different colors of the ECD slice are clearly shown. Green where it is greater than predicted, and purple where it is less than predicted. The green color shows preferential paths of electric current, which imply preferential paths of groundwater. Red arrows have been added to highlight these paths. The large arrow indicates the majority of electric current flow from the east hillside down into the Wells Formation. The small arrow identifies flow from the runoff recharge area to the underlying Wells Formation. Due to pumping from the industrial well and its capture zone, water flows toward the industrial well. The red X identifies an area directly beneath the utility corridor, which is unrelated to meteoric flow paths. The view has been changed to look at a vertical slice oriented north and south. This slice is 750 feet east of the industrial well. Notice the red arrow coming from the lower side of the inversion slice, indicating deep preferential flow of electric current into the Wells Formation aquifer, which then heads toward the industrial well as shown. The detention ponds are also included in this view. There is no indication in the ECD model that the ponds leak water. Now the view has been switched to plan view. An ECD slice is shown at elevation 7,250 feet, with east at the top of the screen. Notice the circle near the center of the survey, which indicates where electric current flows downward from east of the runoff recharge area. This is the same location as the given flow path arrow. Finally, A panel has been turned on to give a geographical reference. This concludes the description of the inversion results for survey number 1. The ECD model suggests that the selenium concentrations originate from the hillside east of the runoff recharge area and flows west as it migrates deeper and eventually northwest toward the industrial well.